Alright, so today's lesson is over solving with multiple angles. So all I mean by that is yesterday's lesson we worked with purely things that had, how can I put this, a single variable in the angle spot in the argument. So if we look back at these lessons from yesterday, you can see we have cosine of x, we have tangent of x, we have sine of theta, sine of x, cosine of theta. So you can see that the variable is always just a single entity by itself. But today we're going to work with multiple angles. So that's where our angle is actually something times x or something added to x. You can kind of think of it as like our bx minus c whenever we were graphing. Okay, so this would have numbers attached to the x in the argument. So we're going to talk about how to handle this situation, and it's very similar to what we did yesterday. So the first thing you want to do is think about, okay, what angle would give me a 1 if I took tangent of that angle? So tangent of what angle gives me 1? Maybe let's write that question over here. So tangent of what angle gives me 1? So that's our little question, okay, our little thought bubble. So if you think about that for a little bit, you got to think about your two triangles. But I know this one because I've seen it a ton of times. It's going to be our 45, 45, 90 triangle, or pi over 4, pi over 4 triangle. Because we've got 1, 1, square root of 2. So tangent of pi over 4 is 1 over 1. So we know that the angle pi over 4 makes this equation true. So in the last lesson we would just say, oh okay, x equals pi over 4. But this time we're not just going to say x equals pi over 4. We're actually going to say 3x equals pi over 4. Because this angle has to be pi over 4 for this equation to be true. So we set 3x equal to pi over 4, and then we solve it. Okay, but another thing that we need to take note of here is that we do need to add 2 pi in on the end so that we can get all possible solutions. So I'm going to highlight a couple of things here. First of all, we have to take our angle and set it equal to the angle that makes it true. So the whole thing, set it equal. And then also, we need to remember that for all possible solutions, we have to tack on the 2 pi in all possible solutions. This is just one of our answers. Remember, pi over 4 is the one for the first quadrant, but we also have to think where else is tangent positive. Well, tangent's positive in the third quadrant. All students take calculus. So it's also positive here. So we have to find that angle whose reference angle is pi over 4 in the fourth quadrant, or third quadrant. And so we have to do a little math here. We've got to add pi plus pi over 4 to get that full angle. So hopefully we know by now that pi plus pi over 4, we have to get common denominators. So this angle is going to end up being 4 pi over 4 plus pi over 4. That's 5 pi over 4. Okay, so that's our angle in the third quadrant that makes this equation true. So we've got two little answers here. We've got 3x equals pi over 4 plus 2 pi in, and we've got 3x equals 5 pi over 4 plus 2 pi in. And we're almost done. I mean, that's the exact same setup of what we did in the last lesson. The only thing we have to do extra is we've got to isolate x. So we're going to divide both sides of the equation by 3. in both of these equations. All right, so our first answer is going to be x equals pi over 4 divided by 3. Remember, we can do stay switch switch, so it's going to end up being pi over 4 times 1/3, which is pi over 12, plus 2 pi over 3 times n. So that's our answer for the first quadrant. And then over here, let's simplify our answer for the second quadrant. We're going to get x equals 5 pi over 4 divided by 3. Stay switch switch, that's the same as multiplying by 1/3. So we'll have 5 pi over 12 plus 2 pi over 3n. And this is the answer for quadrant 3. And there we have it. And I'm going to box these in because there's a lot of work around here. And the thing about these problems is they're very algebraic, so there's going to be a whole lot of work. And I want you to make sure that you're labeling things whenever you're working so that I can see that when I grade your work. So like I have my answer here, and notice I said that's my answer for quadrant 1. Here's my answer for quadrant 2. And even though it looks messy, there's a lot of systematic to the way that I have the problem set up. So that's our first example. Let's go ahead and try another one.